Hey Math 20-1s. Today we're going to look at solving systems of equations graphically. All right, now back in grade 10 we solved some systems of linear equations and we did those graphically, so let's do a quick review. A linear system contains two or more linear equations that are considered together. To solve a linear system means to determine the ordered pair xy that satisfies all the equations in the system. A linear system can be solved graphically, and that's what we're going to look at today. So let's recall some important things about graphing lines. One form of a line would be slope-intercept form, and if you recall, that's y equals mx plus b, where m is the slope and b is the y-intercept. If you know those two things about a line, you should be able to graph it. So let's say you're asked to solve this system. X plus y equals 4 and x minus 2y equals negative 2. It means we're going to find the point xy that satisfies both of these equations. Lots of things add up to 4. 1 and 3, 2 and 2, 3 and 1. Negative 8 and 12 add up to 4. So this first equation, x plus y is 4, has a ton of values that satisfy it, but there's only one set of xy values that satisfy both equations. And that's what we're asked to do, solve this system. So if I'm going to do it graphically, I want to put these into y equals mx plus b form and graph the corresponding lines. So x plus y equals 4, if I write it in y equals mx plus b, we're going to get y equals negative x plus 4. If I solve the second equation for y, putting it in slope y-intercept form, I will get this equation, y equals 1/2 x plus 1. Once I've got these in slope y-intercept form, I can go ahead and graph them. So if I have a coordinate plane, I want to graph these two equations. Y equals negative x plus 4 shows up right there. It's got a slope of negative 1 and a y-intercept of 4. So you plot the point 4 on the y-axis. Then you rise 1 and run 1 to the left. Rise 1 and run 1 to the left. You could fall 1 and run 1 to the right. And all lines that fall to the right have a negative slope. So there's our line, y equals negative x plus 4. You guys go ahead and graph the line y equals 1/2 x plus 1. All right. So 1/2 x plus 1, if you graph it, here's what we get. Y-intercept of 1, bang, y-intercept of 1, slope is 1/2. Means we rise 1 and run 2 to the right. Rise 1, run 2 to the right. We could fall 1 and run 2 to the left. Once I've graphed that line, I'm going to look for the point of intersection. All right, so the point of intersection is a solution to this system. So the solution is the intersection of the two lines. These two lines intersect at the point 2, 2. I want to now check in both the original equations to make sure this point satisfies. So go ahead, stop the recording and check in the two original equations back on the first page and make sure that point 2, 2 satisfies both those equations. If you check it properly, here's what you come up with. For x plus y equals 4, we know 2 plus 2 is 4, and for x minus 2y equals negative 2, if I plug in x is 2 and y is 2, the left side equals the right side. Checks out in both equations, therefore it is a good solution. Excellent. Now, solve the system that's not a linear system. We've got one line, y equals 2x squared minus 6. We've got one quadratic, y equals negative 1/2 x squared plus 4. So we're going to use a graphing calculator and find the points of intersection. All right, so I'd like you to get your calculator out. I'm going to show you how to do this. All right, now that we've got our graphing calculators out, let's see what we're going to do. We're going to go to our y equals screen and type in the equations for each function. All right. So the first function we had was y equals 2x squared minus 6. Let's type that into our calculator, and I'll turn that on. The second equation we had was y equals negative 1/2 x squared plus 4. I'll turn that on. So what you want to do now is graph both these. Let me put those in our standard viewing window. So let's go zoom 6 into our standard viewing window. And here's our first function, y equals 2x squared minus 6. Here's our second one, y equals negative a half x squared plus 4. And just like with the linear systems, we're looking for the points of intersection that'll satisfy this system. So here's one point of intersection. Here's the other point of intersection. How do we find them? With our calculators, we go second function, calculate. We go down to number 5, intersect. And you can see the cursor's on equation 1, y1. Great, we want that. Cursor's on equation y2. Excellent, we want that. And now it asks us for a guess. Looks to me like if I go a little bit to the left, that's pretty close to where the intersection point is. If I press enter, one of our solutions is at -2 and 2. Write that down to our notes. X is -2, y is +2. That looks like one solution. Let's find the other solution, where the other point of intersection is over here. Same thing. Second calculate, point of intersection number 5. Again, first curve, yep, y1, second curve, yes, y2. We go to the right now, we're looking for point of intersection now that's somewhere over here. And as long as we're close to that, press enter, it'll give us the correct point of intersection there, which is x is 2, y is +2. So those will be our two solutions to this system of equations. So now that we've done the calculator work, we will write the solutions down. So solutions for the system were -2, 2, and 2, 2. All right. Let's try one more. Solve this system. All right. You guys give it a try. I'm going to pause the video, and you guys should pause it, try it on your calculators, and then you can check and see how you did it. Let's go back to our graphing calculators. We clear the two equations we've got there, and we type in our two new equations. The first one is 3x plus 1. The second equation was -2x squared minus 4x plus 5. All right, so same idea. Let's go zoom 6, our standard viewing window. Looks like we've got a syntax error. So I think that should be a negative sign. And now we graph it. All right, so there's our line, 3x plus 1. Here's our curve, -2x squared minus 4x plus 5. Looks like we got a point of intersection up here, and it looks like there may be one down here. So let's change our window setting so that we have more negative y's, and we can see the other point of intersection. Let's go down to our negative y's, maybe make it -20. Now if we hit graph, we'll be able to see both points of intersection. There's our line, here's our quadratic. I can see 2 points of intersection. Let's find both those points. So second calculate, point of intersection. First curve is the line, excellent, y1. Second curve is our quadratic, excellent, y2. And point of intersection. So we get our point of intersection in this case to be x is 1/2, y is 2.5. So write that down, and let's find the other point of intersection. Same steps. Second calculate, point of intersection number 5. First curve, yep, y1. Second curve, yes, y2. If you don't like using your cursor, we can pick a value for x. It looks like it might be something about -4. So if I say -4, it'll make a guess near -4 for x. And that looks like it's exactly right, -4 and -11. So write that point down. Then we go back to our question and write those in as a solution. So as we said, let's write down those solutions. They are 1/2 and 2.5, as well as -4 and -11. So those are our 2 points of intersection. They are the solutions to this system. All right, we're going to work on this assignment tomorrow in class. And if you have any questions, bring them to class. We'll go over them tomorrow at the start of class. See you then.